Resultant of vectors. This is a single vector whose effect is the same as two or more vectors together. What does that mean? Simply mean that if we have two vectors arranged in this form, acting on an object, no? In this direction, also in this direction, this is F1, this is F2. So these vectors are acting horizontally. No? So our FR resultant here is going to be given by F1 plus negative F2. And they're going in the opposite direction.
Yeah.
Okay, so if we have a situation like this, the same applies. Ne?
Yeah.
Our FR along the vertical is F1 minus F2 minus F2. Then let me show you when we have forces acting on the same object. Ne? I will share the screen after the lesson. When forces are acting on the same object. So let us have this one and this one, this one, this one. This is Fy1, Fy2, Fx1, Fx2. So we need the resultant. So let us first look at our Fx. Fx will be given by horizontal forces. No? That is Fx1 plus negative Fx2. And Fy, it will be given by Fy1 plus negative Fy2. So our resultant Fr is the root of Fx squared plus Fy squared. That is the resultant. No? So let me show you where it comes from. I'm assuming that if our Fy and Fx are both positive, né? This is where our Fr is. And this is the theta, our angle theta. So now, if you look at this one, you can see that we're going to apply theorem of Pythagoras. Né? Do you know theorem of Pythagoras?
Yes.
Okay, so we're going to apply it to get our FR. Our FR is hypotenuse, so FR is equals to FR squared is equals to Fy squared plus Fx squared. So you take out the by square root, you're going to end up by having this. Now at our theta, we're going to use tan of theta is opposite, which is Fy, over adjacent, which is Fx. Therefore, theta is tan inverse Fy over Fx. Fy over Fx. Okay, so let me show you something very much important. When you are dealing with vectors, no? more than one vectors that are not collinear, what you need to know is that you're going to use this type of direction. We call it positive x-axis direction. We call it positive x-axis direction. Eh? Now, we start, this is what you do. You come and put 0 here, 90 here, 180 here, 270 here, right to 360. So this is how the direction goes. in an anti-clockwise cross from x-axis. Nah? This is x, this is y. In an anti-clockwise. Can I also show you the bearing?
Yes. Yes.
Okay, the issue of bearing. Bearing, at least you must write 3 number after before the comma. Nah? So let us have a Cartesian plane here. I want to show you bearing. Bearing, we start from positive y-axis. This is 0. It's like watch. Do you know watch? 360. So this is bearing. We move in a clockwise direction. It shows bearing. It shows bearing. Are you okay with the bearing?
Yes. So,
Okay.
if I may ask, the first graph is showing what? The first diagram.
This one,
Oh, it's just, yes.
positive x-axis direction, right?
So you use it when you're being asked about
When
relative to
when
the.
when yeah, when you are asked to calculate the resultant of vector, I want to show you where to apply this diagram now, right?
Okay.
Yeah, let me have. I'm going to do one example, then you will do another one, right? I will give you time
Okay.
to do the other example. So I want to show you with this first example. First example. It says that calculate 6 plus 11. Okay. Uh, calculate the resultant. This is exam type problem. Né? Let me see if I can do it here. No, let me upload it. Let me upload it. Let me upload it. I want to upload this diagram. What is the diagram? Okay. And it vectors in 2 dimension. Some activities. I think so. I think so. Okay, and which one? Where is that other one? Oh, the one that I want you to do is where in the test. Yeah, okay, I find it. All right, let me load this one. Here is the question. This is the exam type problems. Exam type problems. Can you see the marks that this question has?
Yes.
It's about 15 marks because there is definition there and calculating the magnitude of resultant and calculating the direction of the resultant. Maybe before this, let me show you something. Yeah, there is something that I must show you before we can do that. Every vector has components, right? Every vector. has components, has horizontal component and vertical component. Horizontal component of a vector. Horizontal component of a vector is defined by, let us suppose this one is our vector f. So this vector has component. We have fy, and this one is called fx. Here we're going to have the angle. Therefore, horizontal component is fx. Fx is equals to f cos of theta because it's the adjacent. What about vertical component? It's fy f sine theta because it's opposite. Nah?
Yes.
These are the formulas that you have to know. For us to do that question, we need this as well. This is what we need. And this is the most important thing that we need to answer that question. Let me bring back the question. Let me bring back the question. Yeah, here is the question. So if you check, it's saying that 3 forces 5, 4, and 3 acting on the object in the same Cartesian plane. Determine the term resultant vector. Resultant vector. So it's just the definition. Sometimes they will say resultant force. It just is the force whose effect is the same as two forces acting together. This one is a resultant vector, a vector whose effect is the same as two or more vectors acting together. That is the definition. So I will not write the definition. Now, we are moving to 2.3.2, which says that calculate the magnitude of resultant force acting on the object using the component method. So we're going to use the table. We're going to use the table. In this table, we have 5 newtons. We have 3 newtons. We have 4 newtons. And here we have total. Here we have fx, here we have fy. So how do we deal with fx? Is f cos of theta? No?
Yes.
This one is f
Sine theta.
sine theta. Now, when you look at the 5 newtons, what we need here is just the direction, the angle theta. No? So the first thing that we're going to do is to assign zeros, angles. We're going to say 0, 0, 90, 180, 270, 360. What is the angle of 5 newtons force? It's 90. Can you see that?
Yes.
Therefore, we're going to apply the formula now. F cos of theta. This is 5 cos of 90.
90.
0. Press the calculator. You get 0. Is it true?
Mr. I'll be back now. Please forgive me, please. Oh, sorry, I'm back. Sorry.
Okay, no problem. So if you press 5 cos of 90, you will get 0. Cos of 90, cos of 270 is 0.
Yeah.
Is it okay?
Yes.
Okay. Now we're dealing with 5, so we're going to also look at this one. Yeah, 5 newtons. You're going to say a sine is sine, sorry. I use cos instead of sine. Sine of theta is 5. Sine what?
Mal, wait. Sine 90.
Sine 90. We use same angle, right?
Yes.
So this is 5. Level.
Yes.
Okay, let us move to the next one. 3. F cos theta. What is our F? It's 3. Cos, let us check the angle. What is the angle where 3 is? Is 0. No?
0.
Then that is cos of 0. The answer is 3. We do likewise with this other component. Then 3 sine of 0. The answer is 0. Press the calculator. Sine of 0 is 0. No?
Yes.
Okay. Then let us move to the last one, which happens to be 4.
4 Newtons.
F cos of theta. So this is for cos of, if you check, we're given 45 then. Eh? So 45 is not the angle. The angle, we count it this way, right? Meaning that
Oh,
is 360 minus 45.
40.
And the answer is 315. 315 is equivalent to negative 45. Ne? If you
Okay.
move in the negative, we're going to have negative 45. Is that clear?
Why are we moving with it in anti-clockwise direction?
We can move in an anti-clockwise, but we're going to have negative angles. I tell that this one is just math application. I'm just applying mathematics here. But the correct direction is to move in an anti-clockwise direction from positive x-axis to backwards, then to the same position. So this is the correct one.
45.
But we can also,
Why is it only 45?
why are we not using 45?
45.
Are you saying why are we not using 45?
Yes.
Okay, the reason is simple. The angle that we measure from positive x-axis. We measure angle from positive x-axis in an anti-clockwise direction. That is why we said this one is 90. Can you see, is this not 90?
Yes, it's 90.
So if we had another force,
Oh.
if we had another force, we're going to say it's 180. You see that force in red.
Yes.
If we had another force this direction, we're going to say it's 270. Né?
Yes.
Then
Oh, I
now
see.
we are moving to here. So this is the angle. The angle that we are dealing with is this one, not this small angle 45. So we're going to subtract 360 minus 45. Then we're going to have 315. 315 is the same as negative 45.
45.
Because if you take 315, negative 45 to the other side, it's going to be positive. Né? When you add it, you get to 360. Is that clear?
Yes.
Okay. Now, back to our problem. We are saying is what is 315. 4 cos of 315. I need to make sure that you know where does 315 come from. What is the answer?
Oh, let me calculate it. Where is my calculator? It's 4 cos negative 45.
Yeah.
It's 2 of square root 2.
It's what?
Decimals, it is 2. In decimals, it is 2,82.
2,82. Very good. And it's positive because cos is positive in the fourth quadrant. No?
It's 83.
Rounding off, no?
Sorry. Yes.
Good. Okay. The reason why I'm saying it's positive is because cos is positive in that quadrant.
Okay.
F sine theta. So this is for sine the same 315. What is the answer? Negative
4 sine and 50.
315 or negative 45.
Okay. It's negative 2,83. Negative 2,83.
The same.
Yes.
Ne?
Yeah.
Now we need the totals now. When we deal with the total, we're going to say 0 plus 3 plus 2,83 is 5,83. Ne?
Yeah.
You say 5 plus 0 plus negative 2,83. This is equals to 2,
Let me calculate it. 5 plus, okay, negative 2,83. 2,17.
2,17.
Yeah.
Then we have our fx and our fy. Ne?
Yeah.
We go straight to the formula now. F is equals to fx squared plus fy squared to the root. This is what is our fx? Fx is 5,83. Fy is 2,17. You just press the calculation, give you the answer.
Square root 5,83 squared plus 2,17 squared. The answer is 6,22. 6,22.
6,22
622.
newtons. Ne? And you are done with the magnitude. You are only left with what direction? If you check, the second question says, the last question says, calculate the direction of resultant force. So how do we calculate direction? You remember tangent of theta equals to Fy over Fx. So theta is inverse tan Fy over Fx. In this case, our Fy is 2,17. Our Fx is 5,83. What is the answer?
Okay, wait.
Inverse tan.
Over 5,83. The answer is 20,42. 20,42
degrees. No? 20,42 degrees. So this is the answer. It's our but we are not allowed to leave that direction in that format. No?
Okay.
If you check both the y fy and fx are positive, né?
Yeah.
Meaning that they are at the first quadrant, then this is our f. This is our theta. Now, our theta, we find it to be what? 20,42, né?
Yes.
So direction is going to be east, theta, north. That is east, 20,42 to the north. We are starting going east, né?
Yeah.
Then as we go north, after the angle, we will find our vector. That is what we are trying to say. Is it clear?
So you are giving your answer in a bearing form.
Come again.
You are giving your answer in a bearing form.
This one is not bearing, né?
Yeah.
That's the positive x-axis direction. Okay, let me show you when we deal with bearing, right? From this question. Suppose the examiner says, calculate the direction of resultant force in bearing. So this is just our direction east. We're going east. Then we go 20,42 to the north. This is our direction. But when we look at bearing, you must write at least in 3 decimals. Né?
Yeah.
So this is our angle. Let me change the color so that you can see. This is the angle. Yeah, one of this angle.
Yeah.
That is the angle that we're looking for. And that angle is what? And then this one is 20,42. What will be that
Yeah.
angle? We're going to 90 minus 20,42.
90 minus 69,58. 58.
16,58. So that is
Yeah.
our angle. So we measure bearing from positive y-axis. So that will be our bearing. It is going to be we are going north, right? Or you can just say at a bearing of, it's up to you. Né? You can say north 69,58 east, or you can say at a bearing of 069,58. At least before the comma we must have 3 digits number. Né? These represent
Come
bearing.
on.
At least before the comma, we must have 3 numbers. Né?
Okay.
That is why we're saying 069,58. So this is the bearing. The other one is positive x-axis direction. Né? So I want to load this other one. Where is that one? What is the name of that line now? So can you please try this one? Try this one. You have 10 minutes.
Okay.
Try this one.
And F and